Hello, I'm Avi Loeb. We need to talk, not about the weather, not about politics, and not about the daily noise that fills up our social media feeds. We need to talk about something that is happening right now over our heads in the vast theater of the solar system. Something that, quite frankly, keeps me up at night, not out of fear, but out of a deep, restless curiosity. You've probably heard the recent reports. You've seen the press releases from NASA regarding the interstellar object we call 3I, Atlas. They've released data, they've shown charts, and they've given us the official line. But today, I want to invite you to look at what they didn't show you. Sometimes, in science, the most important data point is the silence. It's the thing that isn't said. And when I reviewed the data presented by NASA on 3I, Atlas, the silence was deafening. It was so loud, in fact, that it drowned out almost everything else. They completely omitted any serious discussion about the object's size. Now, you might ask me, Avi, why does that matter? It's a rock in space. Who cares if it's big or small? It matters because size is not just a number. It isn't just a statistic you put on a baseball card. In astrophysics, specifically when we are dealing with an intruder, an object entering our solar system from the outside, size is the anchor. It is the foundation. It is the central clue upon which every other measurement relies. If you don't admit how big the object is, you cannot accurately calculate its mass loss. You cannot understand its dust production. You cannot make sense of the non-gravitational acceleration that moves it differently than gravity suggests. Everything hangs on the size. And yet, silence. Let's look at the reality. We have constraints. We have data from the James Webb Space Telescope. We have data from the MAVEN mission's observations of the UV halo surrounding this object. When you do the math real, unvarnished physics, the nucleus of 3I, Atlas, isn't a pebble. It is likely 5 kilometers across. 5 kilometers, possibly even larger. Do you understand the scale of that? We are not talking about a typical space rock. We are talking about something that is orders of magnitude larger than anything we have ever detected from outside our solar system. This isn't just another data point. This is a Leviathan. And pretending it's just another comet is like finding a whale in your swimming pool and telling everyone it's a goldfish because you don't want to rewrite the rule book on swimming pools. This object is estimated to be 1,000 times more massive than the second interstellar object we found, Borisov. 1,000 times. And if we compare it to the first one, Oumuamua, it is more than 1 million times more massive. 1 million times. Think about that number. If Oumuamua was a single grain of sand, 3I, Atlas is a boulder. And NASA, well, they are focusing on the grain of sand while the boulder casts a shadow over the entire study. Why? Why ignore the biggest piece of the puzzle? Because when you acknowledge the size, you have to acknowledge that our current understanding of the universe is broken. And that is a scary thing for a bureaucracy to admit. Let's talk about probability. I am a physicist. I live in a world of statistics. Statistics are the roadmap of expectation. They tell us what is normal and what is an anomaly. Imagine you go fishing in the ocean. You cast your net. The first time you pull it up, you catch a minnow. Okay, expected. The second time, you catch a slightly larger fish. Fine. But imagine if on your third cast ever in the history of fishing, you pulled up a blue whale. That is what 3I Atlas is. Statistically, based on everything we know about planetary formation and debris fields, we should have detected 1 million Oumuamua-sized objects before we ever saw one thing the size of 3I Atlas. We should have seen 1,000 Borisovs before we saw this giant, but we didn't. We saw this one. Number 3, this statistical bias suggests something profound. It screams at us that our current expectations about interstellar debris are wrong. It suggests that the models we teach in universities, the models printed in textbooks, might be fundamentally flawed. Or it suggests that 3I Atlas did not form in a conventional way. If you walk into a room and see a person winning the lottery 3 times in a row, do you assume they are lucky, or do you assume the game is rigged? Nature doesn't usually play tricks like this. When we see an object this massive, this early in our observation history, it demands full scientific attention, not omission. It demands that we ask, where did this come from? The sheer mass of 3I Atlas implies that ejecting it from its home system required tremendous energy. You don't just lose a 5-kilometer mountain into deep space easily. It requires violence. It suggests this object was formed in a rare environment or was ejected by an extreme event, a stellar flare of apocalyptic proportions, a catastrophic collision between planets, or a tidal disruption where a star ripped a world apart. Or it implies a different origin entirely, one that we are hesitant to whisper in the halls of academia, but one that we must remain open to. But the size isn't the only thing NASA skipped over. There is another anomaly, something so elegant and yet so suspicious that it feels scripted. Let's talk about the trajectory. Space is 3D. It's messy. Objects come from all directions, up, down, left, right. When an object enters our solar system from interstellar space, it should come from a random direction. It shouldn't care where Earth is. It shouldn't care where Mars or Jupiter are. And yet, 3I Atlas arrived aligned almost perfectly with the plane of the planets. Imagine a dinner plate. The sun is in the middle, and all the planets orbit on the flat surface of the plate. This is the ecliptic plane. Random space rocks should come crashing through the plate from above or below, but 3I Atlas, it slid right in along the plate. It coasted in on the same level as us. This alignment allowed it to be observed by over 15 different space missions. It was perfectly positioned for us to see it. Such an alignment is a rare coincidence. Statistically, we expect this in only 1 out of every 500 incoming interstellar objects. 1 in 500. And yet, here it is, object number 3. I watched as NASA celebrated this. They patted themselves on the back. Look, they said, isn't it wonderful that we have such a great viewing angle? They celebrated the convenience instead of analyzing the implication. In science, when something is too good to be true, you investigate it. You don't just say thank you and move on. You ask why. Why did this massive object, which shouldn't be here statistically, arrive on a trajectory that perfectly matches our viewing capabilities? Is it a coincidence? Perhaps. I am a man of science. I accept coincidence. But when you stack a 1 in a million mass anomaly on top of a 1 in 500 trajectory anomaly, the odds start to multiply. The coincidence starts to look like a pattern. And patterns are the footprints of something meaningful. Now, let's get into the chemistry. Because if the size is the anchor and the trajectory is the path, the composition is the fingerprint. And then this fingerprint, it doesn't match the suspects. So 3I Atlas shows an unexpected nickel to iron ratio. We are seeing nickel without iron. Let me explain why that is strange. In the natural world, in comets, in asteroids, in the debris left over from the formation of stars, iron and nickel are usually friends. They hang out together. Iron is abundant. If you see nickel, you almost always see iron. But here we have a chemistry that is not natural in comets. We are seeing a separation that nature doesn't typically perform in the cold vacuum of space. However, do you know where we do see this kind of chemistry, where we see high nickel content without the usual iron ratios? We see it in industrial alloys, we see it in aerospace materials, we see it in the heat-resistant shells of engines and fuselages. I am not saying, and hear me clearly, I'm not saying this is definitely a spaceship. I am saying that the material composition looks more like something found in a foundry than something found in a dirty snowball from the Oort cloud. And NASA's report it glosses over this. It treats it as a curiosity rather than a red flag. And then there is the movement. We have observed that this object might be rotating perhaps once every 16 hours. Okay? Rotation is normal. Asteroids spin, but look at the jets. Usually when a comet rotates, the jets of gas and dust wobble, they curve. It's like a garden hose spinning around. The water sprays in a spiral. It's messy, but observations of 3I Atlas show that the jets are tightly collimated, they're straight, they're stable, they're not wobbling wildly as the object spins. This is unusual. How do you have a rotating body with stable, non-wobbling propulsion? It suggests an internal structure or a mechanism that stabilizes the outgassing. It suggests that what we are seeing isn't just ice sublimating off the surface in a chaotic way. It suggests order. And nature, generally speaking, loves chaos. Order usually implies something else. So we have the size, the trajectory, the composition, the stability, and we have NASA. I have great respect for the men and women at NASA. They are brilliant, they are pioneers. But NASA, as an institution, suffers from a very human condition, the fear of being wrong. They are bureaucratic, they are conservative. They want to present data that fits the models because that is safe. Mentioning the size, admitting that this thing is 5 kilometers wide, opens a door they want to keep shut. Because once you open that door, you have to admit that our current models of interstellar debris might be fundamentally incomplete. You have to admit that we don't know as much as we think we do. And that is a vulnerability that institutions hate. But I tell you this, vulnerability is the birthplace of discovery. You cannot discover a new continent if you are afraid to sail off the edge of the map. They are ignoring the biggest anomaly, the sheer mass, and in doing so, they risk missing the most significant insight this object offers. Anomalies are not mistakes in the data. They are nature or perhaps something else trying to tell us something. Imagine if we ignored the anomaly of the orbit of Mercury, we would never have discovered general relativity. Einstein would be a footnote. Imagine if we ignored the mold in the Petri dish. We would never have penicillin. Anomalies are where the treasure is buried. And right now, NASA is walking right past the X on the map because digging there is too controversial. And I want you, the viewer, to understand something. The universe is not obligated to be boring. It is not obligated to follow the rules we wrote down in the 1,950 seconds. It is vast, it is ancient, and it is teeming with potential. When we look at 3I Atlas, we shouldn't just see a rock. We should see a question mark, a 5 kilometer wide question mark. Maybe it is a rock, maybe it's a shard of a destroyed planet, or maybe, just maybe, it is a message in a bottle, drifting through the cosmic ocean, waiting for someone brave enough to read it. I don't have all the answers, but I know this. We will never find the answers if we refuse to ask the questions. And the first question we must ask is, why is it so big? Don't let the silence fool you. The size is the story. And the story is just beginning.